We're going to look at something that I call the fence problem. In this problem, we are interested in enclosing a rectangular area with a certain amount of fencing. We're given information about perimeter and about area, and from that we're going to write equations and find the dimensions of the rectangle. So let's look at this specific problem. We're putting 220 feet of ornamental fencing around a rectangular garden. The area is to be 3,000 square feet. Now that square feet can be indicated with the word square feet or with feet raised to the second power. Our question is, what are the dimensions of the garden? Well, anytime we see the word rectangular and start hearing about feet of fencing, we want to draw a picture so that we can figure out what's going on. So let's just draw our garden here with my high quality rectangle. And what do we know about this? Well, we don't know the width and we don't know the length. So I'm going to label one side W for width and one side L for length. We do know that the perimeter is 220 feet. Anytime you see the phrase feet of fencing or meters of fencing, whatever unit it is, that's your hot tip that this number is the perimeter. So our perimeter is 220 feet. Well, what else do we have? We know the area. We're given the area as 3,000 square feet, so I'm going to write A equals 3,000. Notice that I am not changing the number 3,000. Square feet is just a unit of measure. It has no impact at all on this number. The area is 3,000. Now, to find the dimensions, I need to use what I know about perimeter and area. What do I know about perimeter? Well, 2L plus 2W is equal to the perimeter P. And I can put a number in for P, 220. I also know that the area is width times the length. So WL equals the area, and I can put a number in there, 3,000. Now I have two equations, this one right here, and that one right there, in two unknowns. My problem can be solved, and I'm going to have to use substitution. This is a system of equations, which you may remember working with in the chapter on systems. Let me slide this up a little bit. I'm going to choose to rearrange the equation for perimeter, and let's just say solve for L in terms of W. So I'll write 2L equals 220 minus 2W. And then I'll divide everything by 2. So L is equal to 110 minus W. This I'll then substitute into the equation for area. So W times 110 minus W equals 3,000. Now I need to solve this equation. I'm going to distribute the W, so I'll have 110W minus W squared equals 3,000. Now remember that any time we see a W squared or an X squared coming our way, we need to rearrange this equation and get it equal to 0 so that we can factor. So I'm going to move everything to the right. And that way I can have the coefficient of W squared be positive. So we'll have W squared minus 110W plus 3,000 equals 0. And I'm looking at a nice little trinomial. I want to factor this trinomial, so I'm going to go to my product sum table. My product is going to be 3,000, and my sum is going to be a negative 110. So as you remember from factoring trinomials, that means that I need to multiply two negative numbers together. So I'll get a positive number on the left-hand column and a negative number when I add them up. Well, let's start with 30 times 100. That looks good to me. Let's see where that goes. Well, 30 plus 100, oh, I need them both negative. Negative 30 plus a negative 100 is negative 130. Close, but not quite right. So we could try another set of numbers. 60 and 50 look good to me because 6 times 5 is 30. So negative 50 times a negative 60, and those are going to add up to negative 110, so that's my pair. This trinomial has a coefficient of 1 in front of the squared term, so that means that I can just factor this directly using the 50 and the 60. So I'll have w minus 50 times w minus 60 equals 0. And if you aren't sure about that little shortcut, I'd recommend you talk to your focus group teacher. Now, setting each factor equal to 0, w minus 50 equals 0, and w minus 60 equals 0, we'll find that the width could be 50 feet, or the width could be 60 feet. So which is it? Well, we can go back to this equation up near the top of the screen, that L, the length, is equal to 110 minus the width. So then L is 110 minus 50 if the width is 50, and that gives us 60. Or if the width is 60, the length L is 110 minus 60, which works out to be 50 feet. What does that mean? It means that this rectangle is 50 feet by 60 feet, and it really doesn't matter which of those dimensions we call width and which we call length. So we can say that our rectangle has the dimensions of 50 feet by 60 feet. Now, we always need to check our work. So let's look at how you would check this kind of problem. Again, we're going to use the information we were given about the perimeter and the area. Since our rectangle had a perimeter of 220 feet, we should be able to add up the sides and come up with that. So, just to review, here's our rectangle, and now we've decided it's 50 by 60. The perimeter should be 220. So 2 times 50 plus 2 times 60, is that equal to 220? Well, there we've got a 100 plus a 120, and that does equal 220, so far so good. Also, the area should work out to be 3,000. So when I take 50 times 60, I should get 3,000, and I will, so that one checks out. I'd like to just look at a summary of information about this problem with you. Some things to note. The hot tip to figure out what the perimeter is that phrase feet of fencing. And we need to remember that the equation for perimeter is 2w plus 2l equals perimeter. Area is going to have the units square feet, or square meters, square inches, whatever the dimensions are. You do not change the number associated with the units. And width times length is equal to the area. You are going to get a system and solve it by substitution, and you need to make sure that you check both the perimeter and the area. If you have any questions, be sure to talk to your focus group teacher for a little more in-depth explanation.